So describing sampling distributions, an unbiased statistic. So if you remember what bias means, in general we're talking about leaning towards one result or another. So this is a statistic. And if you recall, a statistic is something that is drawn from a sample. So a statistic where the mean of the sampling distribution is equal to the true value of the parameter, or remember, parameter comes from populations, so the population's parameter being estimated. So you'll recall that statistics come from samples, parameters describe populations, and you can have a mean from a sample or from a population. So if something is biased, it means that the mean of the sampling distribution, and remember here we'd be talking about a complete sampling distribution, is equal to the true value of the parameter being estimated. So whether that's your mean of values, your median, or what have you. So I think in the first lesson we did talk about the different types of statistics and parameters. So the variability of a statistic. So here we're talking about variability, meaning how it can change. Each measurement of the statistic can vary from the mean so we're talking the mean of the sampling distribution and if it's so the mean of the sampling distribution, which is the true value of the population parameter. Okay. So if we only took one sample, and we might find a lot of variability. So how can we reduce variability in a statistic? One way to do that is to increase the sample size. So if I only drew one chip out of that bag, I would have a very small sample size, and I'd have much wider range. I could have 0 proportion of red chips in my sample, or I'd have 100% proportion. So taking 2, I'm going to have more less variability, and if I were to sample the entire bag all at once, then I would have my I would have little variability from the actual mean. In fact, it would be 0. But of course, we don't sample the entire population. So the way to reduce variability, again, is to increase the sample size. Now, you'll recall from the last class, there are costs to increasing the sample size, in that if we have to, let's say, like in the case of the quality control of the batteries in last lessons, example, if we have to destroy our sample in order to test it, we can't be going and testing the entire population. Also, it takes time, and that costs money to sample things. So we want to have a proportion that is sufficient, but not too onerous. So what effect does the size of the population have on the variability of a statistic? So population size, okay, so this is asking about the size of the population. Population size does not affect variability if we are taking an SRS only by increasing the sample size can we reduce variability of the statistic. I'll draw your attention to our box here. Nice box. Sampling without replacement condition. So this is the condition to have independence. If the sample size is less than 10% of the population, then you can assume independence, or in other words, you could say the population is at least 10 times as large as the sample. So this allows us to use often the normal distributions, because our sample is so small that it's not affecting, it's as if, if I randomly take from a big room full of balls and I take less than 10% of them, the fact that I'm not replacing, we can assume is not going to affect our probability. Whereas if I took half of my samples without replacing, I now am affecting the probability. It's just like taking cards out of a deck. If there's 52 cards, you're reducing your chance. Your probability, is changing, because that's 1 out of 52. That's more than 10%. Well, sorry, 1 is, but if I take, let's say, 10 of them, then I'm changing my condition. So statistics, remember, with an S, come from samples. In repeated sampling, we will get different estimates of our parameter. So the idea here is we have variability of statistics. Okay, so let's have a look now at bias and variability and how they relate to each other. So with bias and a variability, bias tells us how good the statistic is as an estimate of the population parameter. So once again, how good the statistic is as an estimate of the population parameter. Variability is the spread of sampling distribution. So if we have a large sample size, then the spread goes down. If we have a small sample size, then the spread goes up. All right, so we're going to draw a picture of each example using the bullseye as our population parameter. Okay, so the center of the target, in other words, the bullseye, is our population parameter. So first we're going to look at bias being high and variability being low. So if variability is low, that means that when we throw our darts, they're all going to be clustered together. They don't change very much from one to the other. But our bias is high, which means we're not very close to the target. So for instance, we could have something like that. Now, what happens if we have okay, so our variability now is going to be high as well. So in this case, our bias is high, we're far off the mark, and our variability is high, so we are going to be kind of all over the place. In this case, we're going to have a low bias, but our variability will be high. So we're going to be pretty close to the mark, but our variability is high, so we're kind of all around it. Okay. And finally, we're going to have low bias and low variability. Also low. And this is our goal. Okay? Our objective when we're doing sampling is to have low bias and low variability. So what low bias means is we're going to be close to the target. And low variability means that the spread is not very much.